So good evening, everyone. Welcome to the class on operation research. Okay, and in this class today, we are going to discuss something which is very important, which is called Big M method. It is an alternate approach of solving simplex method problem when your constraints are greater than or equal to. So whenever we are trying to solve problems on simplex method, okay, and the thing is that whenever we are working on simplex method, we cannot apply the traditional approach of simplex method in all such problem where the constraints are greater than or equal to. We can solve simplex method with a criteria that the objective function should always be maximization and the constraint is be less than or equal to. That is the utmost criteria what we need to follow whenever we are solving simplex method. Okay, 1 minute. Pavitra has a question. Yeah, Pavitra, you have to write all the problems. Yeah, Pavitra, you have to write all the problems, whatever I'm doing. So I think these are self-explanatory that what everything what we are doing, you need to make a note of everything. And then when we'll meet, I'll check your notebook. So please follow this. So here,
Sir, principals are done LPP method, sir.
yes, ma'am. So LPP method, principal sir has done what principal sir has done for you people. Principal sir has done formation of equation. Okay, I what I'm doing teaching you to how to solve the equation. Are you getting me? When principal sir has taught you, so yeah, principal sir has taught you how to write an equation whenever you have a word problem. So word problem kind of question comes always for BCA student. For MBA student, the chances of coming is little bit less. So principal sir has taught you that if you get problem like this, okay, manufacturer produces two types of model M1 and M2. Each model of M1 requires 4 hours of grinding and 2 hours of polishing, where each model of type M2 requires 2 hours of grinding and 5 hours of polishing. The manufacturer has two grinder and three polisher. Each grinder works 40 hours a week. Each polisher works 60 hours a week. Profit on model M1 is rupees 3, model M2 is rupees 4. So whatever is produced in a week is sold in the market. So how should the manufacturer allocate his production capacity so that he can maximize the total profit in a week? This is the question. The principal sir has taught you how to write the LPP equation, how to write the equation that was being taught to you. That maxima of Z is equal to 3x1 plus 4x2. That is your objective function. Okay, where x1 x2 are the number of units manufactured in model M1 and M2, then subject to constraint. Then you learn writing the constraint. What are constraints you have? So grinding, if I talk about grinding, so 2 hours, each model of M1 requires 4 hours of grinding and M2 requires 2 hours grinding. That should be less than or equal to, okay, that should be less than or equal to, so each grinder works this much and you have two grinder and three polisher, this would be 80. Then you learned 2x1 plus 5x2 that is less than equal to 180, where x1 x2 should be greater than equal to 0. This principle sir has taught you how to write this equation. What I am teaching you, first I taught you graphical method. First, I taught you graphical method. Then I have taught you simplex method. By using this graphical or simplex method, I am teaching you how you can find the value of x1 and x2. Are you getting it? So I'm trying to teach you how you can get the value of x1 and x2. Okay, now this on this data, you can use simplex also, you can use graphical also. But problem happens once you know how to construct the equation. In case if the in the equation you get a constraint with greater than or equal to sign. I hope you're understanding when you are constructed the equation. In case what you observe that after constructing the equation, you observe that the constraint is having greater than or equal to sign. So if your constraint is having greater than or equal to sign, then you cannot solve that problem by using simplex method, because in simplex method the constraint should be less than or equal to. I hope you're understanding. Then all such problem is being solved by big M method. This is an approach to solve the LPP problem. Till now we are only talking LPP problem only. We have not went ahead of LPP problem. Direct LPP equations, when we get, how we can solve it. It is very important. We should how to formulate an equation. For it is very important that we should know to how to formulate an equation. Once we formulated the equation, how we can solve that equation. Everything should be important, right? So word problem, you need to know how to create an equation, then you need to solve the equation. Like you read, no, when your schools and all, we read that my brother is 6 years older than me when I was 3 years old. After 4 years, my brother will be three times of my age. So what are the present age of me and my brother? So suppose I ask you that. So the first thing is that what you do, you write the equation. You read the problem, you write the equation, but based on reading on the problem, what you understood. Then the next thing what you do, you try to solve it. So right now I'm trying to teach you how you can solve it. So all these equations, whatever we are doing, you have to understand that the graphical method, when we used, in the case of graphical method, we cannot solve a graphical method problem if you have more than two variables. Graphical method can only be used when you have two variables. One variable you write horizontally, another variable you write vertically. But if you have more than two variables, then graphical method cannot be used. Then you need to think about the another methods. Another method like simplex method. Another method is like a simplex method. With simplex method, you can solve any kind of problem. So this is an alternate way of solving the problem where if your constraint is greater than or equal to. I hope you understood. So talking about simplex method, when we talk about simplex method, when we talk about simplex method can can be applied simplex method can be applied when the objective function is maximization. Simplex method can be applied when the objective function is maximization. When the objective function is maximization, so we can do we can use simplex method when the objective function is maximization. Whenever the objective function is maximization, we can use simplex method. Okay, then what, we can use a simplex method when the constraints when the constraints are when the constraint are having when the constraints are having less than or equal to when your constraints are having less than or equal to inequality. You can use simplex method in these two conditions. You can use simplex method when your objective function is maximization and when your constraint are having less than or equal to inequality. So under these two conditions, you can use simplex method. Okay, under these two conditions, you can use simplex method. Are you getting, everyone? Everyone, are you understanding? So you, under these two conditions, you can use simplex method when the objective function is maximization and when the constraint is less than or equal to inequality. Getting, everyone? Anyone, any doubt? So under these two conditions, you can use simplex method. Here, guys, when you see this kind of scenario here, you both are not working. Means for the simplex method, the objective function should be maximization. Here, if you see, the objective function here is minimization. Here, if you see, the objective function here is minimization. So again, The objective function is not maximization. Okay. If you see the constraint is greater than or equal to. So you can understand simplex method, we cannot use it here. I hope you all are getting it what I'm trying to teach you. You cannot use simplex method here. Why you cannot use? The reason I'm showing you. Clear everyone? Okay. So now guys, simplex now here understand if the objective function, understand guys, if the objective function, understand that if the objective function is minima of z, if the objective function is minima of z is equal to 12x1 plus 20x2, this is your objective function, then maxima of z can be created. Then you can write maxima of z. How will you can write maxima of z if the objective function is 12x1 plus 20x2? So if this is your objective function, then you can convert the minima matrix into maxima matrix. How you can convert the minima matrix into maxima matrix? By changing the sign of the equation. So then this will become minus 12x1 minus 20x2. So if your objective function is minima of z equal to 12x1 plus 20x2, then you can convert the minima function into maxima function by changing the sign of the equation. The whatever the variables are there, if you change the sign of the variables, you can convert minima function into maxima function. Are you getting it right, everyone? So by changing this, you can convert the function into maxima. So you say, okay, sir, I understood this. So now this equation, I can write this equation as maxima of z is equal to minus 12x1 minus 20x. Okay, subject to constraint. What all constraint is subject to constraint? You can write this as, now if this is having greater than or constraint, 6x1 plus 8x2, that is greater than or equal to 100. Here if you see the constraint, here if you see the constraint in this equation, the constraint in this equation is 6x1 plus 8x2, that is greater than or equal to 100. What this mean? This mean that 6x1 plus 8x2, this is equal to 100, or this is equal to 100, or 6x1 plus 8x2, that is greater than 100. So if 6x1 plus 8x2 is greater than or equal to 100, it means that 6x1 plus 8x2, that is equal to 100 or that is greater than 100. Is this clear, everyone? So now if you see here the constraint. So here if you see the constraint here, 6x1 plus 8x2, this is greater than equal to 100. So what I can do to make it equal to 100, so what can I do so that it become equal to 100? So I have to use some slack variables. I have to use some dummy variable so that your LHS side become equal to RHS side. The problem here is that if 6x1 plus 8x2 is equal to 100, then it's fine. But what about the cases when 6x1 plus 8x2, if that is greater than if that is greater than 100? So under that condition, how will you make this equal to 100? Only thing, you have to introduce a negative slack variable here. So by introducing the negative slack variables here, you can make your LHS to be equal to RHS. So first minima objective function, you convert it into maxima objective function by changing the sign of the variables of the objective function, and then the constraint what you are having, this is 7x1 plus 12x2, this I can write as minus 12 minus s2 is equal to 120, where your x1 x2, your s1, your s2, that should be greater than equal to 0. And here you can write plus 0 s1 plus 0 s2. So you introduce two negative slack variable. So here in this problem, you introduce two negative slack variable. The purpose of introducing two negative slack variable, the purpose of introducing two negative slack variable, because two constraints were there with greater than or equal to inequality. Because in this problem we had two constraints with greater than or equal to inequality. So we introduced two negative slack variables here. Clear everyone? Anyone, any doubt? Anyone, any doubt? So now what we'll do, once we get the standard form of equation like this, once we get the standard form of equation like this, okay, once we get the standard form of equation like this, I can write this equation as 6 8 minus 1 0, then 7 12 0 minus 1, then x1, then x2, then s1, then s2, and then it is equal to 100 and 120. You know this. So you know this equation. Now what we will do, we'll create an iteration table and we'll try to solve this equation. Anyone, any doubt? Anyone, any doubt? Whatever I'm teaching you. Anyone, any doubt? Whatever I've done so far. This is how we do, right? Guys, please ask me. Anyone, any doubt?
No, sir.
Clear, right? So these are the steps what we follow one by one to do the equation. Okay, so once we are done with this, what we do? Once we are done with this, then what we do? Once we are done with this, after this, what we do? We create iteration table, right? Hello. What we do after?
Yes, sir.
We create iteration table, right? Once we are done with this, what we do? We create once we are done this much, once we are done this much, what we do? We create iteration table, and by using iteration table, what we do? We create the iteration table where we write x1, x2, s1, s2. Okay, and there here I write s1, s2. Here I'll write 8 6 8 minus 1 0, then 7 12 0 minus 1. Remember, no, 0 minus 1. Okay, then we write theta, we write RHS. Your RHS will be 100 and 120. Your theta. Correct, right? And then we start solving it. This would be 0, this would be 0. Values we'll write the CI value. CI value will be minus 12, minus 20, minus 12, minus 20, 0 0. And then we'll start solving this equation. Any doubt, anyone? These are the steps I have taught you. Yes or no?
Yes, sir.
I hope Lavanya, you're noting down all this. I'll take your notebook. I'll give to the other students. Many students ask me notes and all. I'll give your notes only to everyone. So you everyone understood, right? This all clear. So you understood step by step you can do. And you start finding the ZI value, then you'll find CI minus ZI value, and then probably you will get the solution, the values of the decision variable. That is what we are looking for. This any problem with the steps, whatever I discussed? Anyone? Any problem with the steps which I told you? Guys, please reply. You know, right? You remember, right? This is what we're discussing from beginning, right? Yes or no? Please respond, guys. Yes or no?
Yes, sir.
So, what are the steps when you get a problem, linear programming problem? What are the steps you follow whenever you get a linear programming problem? What all the steps you people follow whenever you get a problem? What you do with the problem? First thing, what you do with the problem whenever you get a linear programming problem? Tell me, what is the first thing you do in the problem? If I give you LPP problem, what is the try to do in the problem? What is the first thing? If you give LPP problem, what is the first thing I try to do in the problem? The first thing, whenever I get
Finding
a
the formulations.
finding the formulation. So for first I two things can I give you? I can give you a word problem. I can give you a word problem, or instead of giving you word problem, I can directly give you the equation. So if I give you word problem, then the first you have to spend time writing the equations for the problem. Once you have written down the equation for the problem, then you work hard to get the solution for the problem. The if you are using simplex method to find the solution for the problem, the first thing you see is that the objective function should always be maximization. If the objective function is maximization, okay, and if your constraints are less than or equal to, you can solve the problem by using the traditional simplex method approach. If you are solving the problem by traditional simplex method approach, then your constraint should be less than or equal to. So why less than or equal to constraint should be the constraint what you are using is less than or equal to, so that you can convert by introducing by you can solve, you can make the constraints with less than or equal to, with you can make them with equal to sign by introducing slash, and then you can solve the problem to get the answer. The real issue happens when you face the real issue, guys. You will face the real issue when you have greater than or equal to constraint, guys. If your constraints are greater than or equal to, then then you have to introduce a negative slack variable into the problem. The problem with the negative slack variable is you cannot work on iteration based on the negative slack variable, guys. So this logic of iteration, whatever I have taught you so far, the logic of iteration, you cannot apply on the negative slack variable. So this negative slack variable will not help you to solve the problem by using iteration table. So negative slack variable, if you're using negative slack variable, so the negative slack variable will not give feasible solution, will negative slack variable will not give feasible solution. Negative slack variable will not give feasible solution. So you cannot start solving the problem with the negative slack variable, guys. So if you see the problem like this, if you are having problem like this and you are trying to solve this problem, if you are having problem like this, you are trying to solve the problem, And if you have introduced negative slack variable into the equation to make your constraint to make your constraint like with equal to sign here by using negative slack variable, you remove the inequality sign to make the constraint with sign. Then under this scenario, if you trying to put them under the iteration table, you cannot put iteration table. The problem is that negative slack variable will not give you the feasible solution. So this way you cannot solve the problem, guys. You want to solve the problem, then what you can do now coming back to the problem. Now coming back to the problem. Now again you'll feel frustrated. So what we can do to get the problem? What we can do to get the problem, guys? Your problem was 12 minima of z is equal to 12x1 plus 20x2 subject to constraints. What all constraints we have? Subject to constraint 6x1 plus 8x2 that was greater than equal to 100. The problem here is that the constraint, what are the constraint, what all are there, they are there with greater than equal to sign. That is the problem. That is the problem. So guys, you have understood that the problem with the simplex method, when the simplex method is having greater than or equal to sign, the problem what we are having is that we have to introduce a negative slack variable here. And if we introduce a negative slack variable, that negative slack variable, it cannot be the part of the given iteration table. Okay, because then it will not give you the feasible solution. So what you can do, guys, to come out of the solution, what you can do, what should I do to get the solution from this kind of situation? So when you're gonna face this kind of situation, what you can do, you can you can introduce artificial variable. You can introduce artificial variable. You can introduce artificial variable like let their a1 and a2. Let their a1 and a2. Suppose you can introduce artificial variable like a1 and a2. Okay, what are these? These are artificial variable called a1 and a2 uh, where the number of artificial variable introduced, where the number of artificial variable, where the number of artificial variable, what we are introducing here, that number of artificial variable, it depends upon the number of constraint. It depends upon the number of constraint. It depends upon the number of constraints. It depends upon the number of constraint with greater than or equal to sign, with greater than or equal to sign. So here what you can do to solve these kind of problem, okay, what you can do, because ultimately you have to solve the problem, right? Here, so that's why we use this method and we call this method as a big M method. So here, whenever you are solving the problem, having constraint greater than or equal to sign. Whenever you're trying to solve the problem, we're having constraint with greater than or equal to sign. If you are having constraint with greater than or equal to sign, then the best way to solve this kind of problem, the best way what you can do to solve this kind of problem is to introduce artificial variable. Okay, where the number of artificial variable what you'll introduce, that number of that artificial variable will be equal to the number of constraints what you have with greater than or equal to sign. Okay, guys. Okay, and the coefficient of this constraint, where the coefficient of these constraints, where the coefficients of the artificial variable what you introduced here, the coefficient of the artificial variable being introduced in the problem, where the coefficient of the artificial variable what you introduced here, coefficient of artificial variable what you introduced are basically of minus m. is minus m. What is minus m, sir? What is minus m? So what is minus m? So understand, consider m. What is m? M is very large number. M is very large number close to infinity. Consider m is very large number close to infinity. So you can understand what is m. M is somewhat equal to infinity, not exactly infinity, but close to infinity. So then minus m is very small number. Then minus m is very small number close to. Then minus m is very small number close to 1. The purpose is here is that you are trying to introduce those variables into the equation. The purpose here is that you are trying to introduce those variables into the equation which should not impact the solution of the equation. Are you getting me? So we want to introduce those variables that so that those variables should not impact the overall calculation. Overall calculation, what you are trying to do here, it should not get impacted because of the introduction of these variables. So I hope you are understanding this. So that's why I'm introducing these artificial variables. So uh, I'm introducing these artificial variables. These artificial variables with the coefficients minus m, where m is very small number, it's very close to 1, where m was very big number, which was close to infinity. You can understand this. So the purpose of introducing this artificial variable, what is the purpose of using this artificial variable? To create a situation that we can ultimately use them into the basic iteration table to get the feasible solution for the problem. Clear everyone? Anyone, any doubt? Clear everyone?
Yes, sir.
So now what I'll do, I'll write the same problem. Now I'll write the same problem as maxima of z. So if I'm writing maxima of z, I'll change the sign of the variable of the objective function. Maxima of z is equal to minus 12x1 minus 20x2 subject to subject to uh, subject to 6x1 plus 8x2. So 6x1 plus 8x2 minus 6x1 plus 8x2 minus s1 plus a1 artificial variable is equal to 100, and 7x1 plus 12x2 minus s2 plus a2 is equal to 120, where x1, x2, s1, s2, a1, a2 are greater than or equal to 0. And then you can write this one for this as plus 0 s1 plus 0 s2 minus ma1 minus ma2. Clear everyone?
Yes, sir.
Okay everyone. So now what I can do, I can write down the same problem. So writing the problem in the standard form, writing the problem in the standard form, writing the problem in the standard form. I can write down this problem in the standard form. This will be 6, 8 minus 1, 1, 6, 8. So this is x1, x2, s1, s2, a1, a2. 6, 8 minus 1, 0, 1, 0. Then 7, 12, 0 minus 1, 0. This I'm writing in standard form. The same problem you can write in standard form. This when you multiply with when you multiply with x1, x2, s1, s2, e1, e2, then this is equal to 100 and 120. Clear everyone?
Yes, sir.
So once you have understood this, once you have understood this part, okay, once we have written down this, now we can create an iteration table. And so when we create the iteration table, in the iteration table, we'll only start the iteration table with the artificial variable a1 and a2. I'll write them these values as 6, 8, minus 1, 6, 8, minus 1, 0, 6, 8, minus 1, 0, 1, 0, 1, 0, 1, 0. And here I'll write as 7, 12, 7, 12, 0, minus 1, 0, 1. 7, 12, 0, minus 1, 0, 1. And then we have x1, we have x2, we have s1, we have s2, we have a1, we have a2. Then we have ci values. ci values I can put here minus 12, minus 20, minus 12, minus 20, 0, 0, minus m, minus m. The RHS value are 100 and 120. And this is theta. Any doubt, anyone?
No, sir.
So now what I can do, I can find Zi value. So Zi value will be minus 6m. Zi value will be minus 6m, then plus minus 7m. This will be minus 13m. So this will be the first value. Second one will be minus 20m, minus 8m, minus 12m. This will be m. Then this will be m. Then this will be minus m. Then this will be minus m. Any doubt, anyone? So once you find the Zi value, now you can find Ci minus Zi value. Then you can find Ci minus Zi value, Ci minus Zi value, Ci minus Zi value. So minus 12 minus 13m. So this will be 13m minus 12. Then this will be minus 20 minus 20m. So this will be 20m minus 20. This is Ci minus Zi minus m. This is minus m. This is m. This is 0. Minus m plus m. This is 0. So out of all Ci minus Zi, see the value which is largest. Okay, so see out of all Ci minus Zi value, see the value which is largest. Guys, you have to understand here, guys, you have to understand that if you see, I think you might get confused. Many of you maybe get confused. Yeah, so you may think that which is bigger value, 20m minus 20, 20m minus 20, 20m minus 20, or 13m minus. You might think that which is the bigger value. You have to understand, guys, m is very large value. M is very large value. Think on a number line. Think of a number line. Think of a number line where the 12 will lie. Okay. And then think where the m will lie. M is very large value. So here to determine which is bigger, okay, you don't have to worry about, you don't have to see this. What is this? To decide which is bigger, you don't have to see this because this doesn't matter. So it is out of 20m minus 1 and 2 or 2m minus 1 crore. Which is bigger value? This will be bigger value. I hope you are understanding. M is very large value, guys. So the next term next to M, that doesn't matter what. So you need to understand which is bigger out of 20m and 2m, which is bigger. Definitely 20m will be bigger. Please understand the possibility here. So now coming now here out of this value, so the bigger value is 20m minus 20. So you can find the theta. So the theta will be 100 by 8 to decide that you know that x2 is entering into the solution. You know that very well that x2 will enter into the solution. Now x2 will replace either a1 or either a2. So which variable x2 is replacing? For that I'll find theta. The theta of this will be 12.5. The theta of this is 120 by 12 is equal to 10. So out of both the value theta, the minimum theta belongs to A2. 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 Okay, so the minimum theta belongs to A2. The minimum theta belongs to A2. So it means what is your pivot element? Your pivot element is 12. It means your pivot element is 12 and 8 is your constant. Constant when you do the calculation of A1. So the pivot element is 12 here. So guys, you understand, no? This means X2 is gonna replace A2. X2 is gonna replace A2. X2 will replace A2. X2 will replace here A2. X2 here replace A2 and the pivot element of that will be 20. So X2 will replace A2. Guys, you have to understand that the X2 will replace A2. X2 will replace A2 and the pivot element will be 12. And the pivot element will be 12. So how to find the values of X2? That will be 7 by 12. So that will be 12 by 12 means 1. That will be 0 by 12 means 0. minus 1 by 12 minus 1 by 12, 0 by 12, 0, 1 by 12, 120 by 2. Clear, everyone? Fine. Now to find the value of A1. Now how will I find the value of A1? Now A1 value, to find the old element of A1, we'll write the old element of A1. 6, 8, minus 1, 0, 1, 0, 100. So this is the old element of A1, and then the new element of X2. These are the new element, that is 7 by 12, then 1, then 0, minus 1 by 12, 0, 1 by 12, and 10. And the constant here for the calculation of new values of A1 is 8. So for the new values of A1, we use a formula called old element minus 8 into new element. So guys, if you solve this, this is 6 minus 8 into 7 by 12. This is 6 minus 2 by 3 into 7. This is 6 minus 14 by 3. This means 4 by 3. This is 8 minus 8 into 1. This is 0. This is minus 1. This is 2 by 3. This is 1. This is minus 2 by 3. And this is 100 minus 8 into 10, 80. This is equal to 20. Okay, now write down these values here. A1 value 4 by 3, then 0, minus 1, then 2 by 3, then 2 by 3, 1, minus 2 by 3, then 20. Anyone, any doubt?
No, sir.
Sir, like this, we will write an exam, sir.
Yes, sir. Do little bit neat work in exam.
What about the statements, sir? Statements.
Statements and all not require, little bit of introducing standard form, all that little bit you have to write. and your work will be done. The exam, all this matters more on solving this and all, because it will take a lot of your time. It's not very easy thing. Are you getting me what I'm trying to tell you?
Yeah, yes, sir.
You don't have to spend time writing theory and all about this and all. Means then you are gone. But anyway, you have very less time to do this. One problem will take 20 minutes. If you start writing theory also little bit here and there, means you waste lot of your time. And again, these all come for 10 marks. They are not 30 marks. So if you are writing steps and all properly, your examiner will give you 10 out of 10 or max to max 9 out of 10. More neat work you do, more marks you get. So girls and all, they do neat work. They may draw pencil, or with pencil they draw the line. The lines are straight. All that will give more marks. If simply you draw the line like me, what I'm drawing, not very straight, then you may simply examiner will deduct 1 marks or half marks because of neat work. So neat work is required. So find zi value, find zi value, zi value. Zi value will be what? Zi value will be minus 4 by 3 minus 120 by 12 minus 4 by 3 m minus 140 by 2. Next one is minus 20. Then next is m. Then this is minus 2 by 3 minus 2m by 3 plus 10 plus 5 by 3, or let it be 20 by 12. Everything 12 12, I so keep writing them like this. Minus n. This is 2m by 3. This is 2m by 3 minus 20 by 12. The zi value, this value correspond to, this value will be minus 20m plus 200, not minus 1, still minus 200. Clear, everyone?
Yes, sir.
Sir,
Yeah, tell me.
sir, will you take the financial accounting and management subject also?
Financial accounting, not very much. I'm good with statistics. Mathematics
Okay,
subject I'm good with. So
because next week we have exam of third sem, so that's why main exam.
yeah, third sem. Now you are okay,
You have fourth BCA.
okay. I'm not very good
We
with.
were having some doubts about the previous semester which we were not understanding. That's why if I asked you if you
Okay,
can.
got it. What doubt you have? I'm not good with accounts, but just ask me question. I'll figure out some.
Some problems which are related to that one. We need to revision of the problems.
Okay. You know Ranganath sir?
Which sir?
Ranganath sir.
No sir.
Ranganath sir. Okay. How can I help you? You do one thing. You have my number.
Yes sir.
You do one thing. You send me those questions. I'll figure out someone who can do that question, and I'll try.
Okay.
How many questions are there?
Also, we are doing some problems like some methods. These methods.
Okay. No, one of my student is a chartered accountant. I thought I'll send these questions to him. So, some methods you have doubt for. You do
Yes,
one
sir.
me the question. I'll see what I can.
Okay, sir.
I'll try to help you as much as I can.
Okay.
So because I am from non-commerce and science guy. So BSc maths. So accounts I studied in my MBA, but I'm not very much good with accounts.
Okay.
So ZI clear, right, everyone? ZI you're clear. So now CI values, CI values. CI values you wrote in the beginning. -12, -20, -12, -20, then -12, -0, 0, 0, 0, 0, 0, -m, -m. So who taught you accounts in last semester?
Tarangini ma'am, but she left the college. That's why I asked you, sir.
These problems, big problem in college.
In our college, almost everyone has left. Half of them.
Teaching world is struggling. We all as a teacher struggling like anything. Anyway, I'll help you. Don't worry. Now this so CI values already the CI values and ZI values So now CI ZI, then you can write CI minus ZI. If I write minus ZI, then this minus will become plus 4 by 3 plus 4 by 3m. Here this will be minus plus 140 by 12 minus 12. So this will be 4 by 3m minus 144 plus 1 plus 140 is minus 4 by 12. So this is 4 by 3m minus 1 by 3 minus 1 by 3. This will be 0. This will be minus m. This will be 2m by 3 minus 5 by 3. This is 0. This is 1, 2, 3, 4, 5. Then this will be Ci minus Zi. So Ci minus Zi. So Ci this minus m minus Zi minus 2m by 3 plus 20 by 12. So this will be minus 5m by 3 plus 5 by 3. So you can see guys, out of all Ci minus Zi, which is bigger value? This is a bigger value. You cannot this out of these two, you can see this is bigger than this is bigger than this. So out of all Ci minus Zi, see the bigger value. This is a bigger value. Now, if this is a bigger value, means this value correspond to what? This value correspond to x1. It means x1 is gonna enter into the solution. You are sure that x1 will enter into the solution. It means x1 will enter into the solution. So for that, find the theta. For that, find the theta. Find the theta. So theta, this would be 20 divided by 4 by 3, which will be 15. Okay. And this would be then just 10 divided by 7 by 12. This will be 120 by 7. Will be 50 means 14. No? 120 by 12, 7 by 12, 120 by 12. So you get 50, 550. So this is 20 divided by 4 by 5, 4 by 3. This is 5 15. This is 10 divided by 7 by 12. This is 120 by 7. 17. No, that's not 17. 1 by 7. 17 sevens are 119. So out of this, which is a smaller value? This is a smaller value, right? So means this correspond to what value? Called A1. It means X1 is entering into the solution and A1 is leaving the solution. It means A1 is leaving the solution and X1 is entering into the solution. Any doubt, anyone?
No, sir.
So the X2 has already entered to the solution. Now X2 is already entered into the solution. Now X2 is already entered into the solution. Now what is going to happen? Now in place of A1, the X1 will enter into the solution. Now in place of A1, the X1 will enter into the solution. So now what we'll do to make sure that A1 enter into the solution, the coefficient of A1 is minus 12, and in place of A1, the X1 will enter into the solution. So after this, what we'll do, in place of A1, I'll write X1. So minus 12 X1 minus 20 X2. So it means what is a pivot element, guys? A pivot element, then it would be 4 by 3. So this is a pivot element, then this would be 1. 0 divided by 4 by 3, 0. This would be minus 3 by 4. Minus 1 divided by 4 by 3. Minus 2 by 3 divided by 4 by 3. 2 by 3 divided by 4 by 3, that would be 1 by 2. Then 1 divided by 4 by 3 means that would be 3 by 4. Then minus 2 by 3 divided by 4 by 3 is minus 1 by 2. And 20 divided by 4 by 3, that will be 15. Clear, everyone? So 4 by 3 is your element. Done, everyone? Then once you're done with, in place of A1, if you understood X1 is coming with the x1 is coming with the pivot element 4 by 3. Now I can find the value of x2. For x2, the constant will be 7 by 12. Can you find the value of x2, guys? Can you find the value of x2? x2, can you try that? x2 values, guys. Put the values of x2. Try by yourself. x2 values, please try by yourself. You will get 0, 1, 7 by 16, minus 3 by 8, minus 1 by 16, 3 by 8, and this is 5 by 4. Everyone try by yourself, finding the value of x2. Write down the old values 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 of x2. 7 by 12, then 1, then 0, minus 1 by 12, 0, 1 by 12, and then 10. New elements, that is 1, 0, minus 3 by 4, 1 by 2, 3 by 4, minus 1 by 2, and 15. Okay, guys, so these are the old values of x2, and the new values what you get, new values you get x1, the new values you get x1, the constant for this equation, what would the constant equation? 7 by 12. The 7 by 12 will be the constant for the equation. So use the formula old element minus 7 by 12 of new element. Use this formula and find the values, guys. Find the value of x2. Do it, guys. I'll join you back in 5 minutes. Do this, everyone. Calculation, you can see the constant was 7 by 12. So 7 by 12 minus 1 into 7 by 12 is 0. 1 minus 0 into 7 by 12 is 1. Then 0 minus, so minus minus plus 7 by 12 into 3 by 4, that is 7 by 16. This is minus 1 by 12, minus 1 by 12, minus 7 by 24. So you'll get minus 3 by 8. Then 0 minus 3 by 4 into 7 by 12. So you solve it, you'll get the answer. 1 minute. So, so you get this value. This is 0, 0 minus 3 by 4 into 7 minus 7 by 12. So this is 4 minus 7 by 16 you'll get, right? 0 minus 7 by minus 7 by 12 into 3 by 4. So this is 4 za. So minus 7 by 16, 1 by 12 plus 7 by 12 into 1 by 2. So 1 by 12 plus 7 by 24 means 24 LCM means 9 by 24 means 3 by 8. Then 10 minus 7 by 12 into 15. So 10 minus 7 by 2 into 15, this you can write as 5 by 4. So 10 minus 35 by 4 means 5 by 4. Clear everyone? Anyone, any doubt with the calculation? So once you are clear with this calculation, you can find the ZI value, the ZI values. You can find the ZI values. So the ZI value, this will be minus 12, minus 20. You can see this CI values was minus 12, minus 20. This is 0. This will be 0. This is minus M. This is minus M. These values doesn't matter. So CI minus ZI, if you see, this will be 0, 0, and all will be negative. Negative value. You can spend time in calculation, but you will get negative value only. Are you getting everyone? So CI minus ZI, all you will get is 0 and negative 1. So that will give you the optimal solution. Any doubt, anyone?
No, sir.
Sorry for inconvenience, guys. So I hope you understood this. So you can spend time solving this and all, but again, in every case, you get a positive value, and then 0 minus that positive value will give you negative only. So the final solution for this problem, if you see the final solution for the problem, so the x1 value is equal to 15, the x2 value will be 5 by 4, and the z value will be how much? So the maxima of z, how much you will get? This is minus 12 into 15. This will be minus 180, and then this is minus, this is 420, no, minus 5, minus 5 into 5, minus 5 into 5 means minus 25. This would be minus 205. This is minus 205. So the minimum value of z will be 205. Anyone, any doubt? So I hope you have understood everything, whatever I've done. So it's time to wind up the class. Thank you, everyone. I'll see you all tomorrow. Take care. Bye, everyone.
Thank you, sir.